Welcome to our second episode of our podcast, Tech Talks. And today's topic is what is a programming language? So let's start the obvious question on what a programming language is to our host.
Hey, hi. Yeah. So, in to put it in layman terms, right? So, programming language is a way of you as a person telling a hardware to do something.
Okay.
Okay. So you can, um, let's assume you can tell a child, right? Go and come here. Okay.
Mhm.
And the child just goes and comes here, right? So you just gave an instruction and child understood. And for that there is a communication channel. You either show a finger, he'll realize that okay, he has to go and come back, or you made a sign language saying like go and come back, or you can tell him in the language that he understands, a communication language, right? So in the same way, you have a hardware, you have a piece of hardware, and you wanted to make use of that piece of hardware to do something, whether it's useful or not, secondary thing, right? But basically, if you want a piece of hardware to do something, the easiest way for us as uh, as like software developers, or a third third party citizens, right? A easiest way to make hardware do something is programming language. Why I mentioned easiest way is because, uh, as the history, if we just go back into the history, right, you would see the feasibility of making use of hardware to do things, right, would get more complex. It's not like today you just sit down and just write, a print hello world, right, and you would see something on the console. That's not how it was as you go like 50 years, 60 years, 70 years back, right? The things are a little bit more complex. um, uh, they even get to a level where you have to use hardware programming to actually do something with the hardware.
Okay.
So the hardware programming is more or less like, putting up multiple transistors, putting up multiple capacitors in such a way, and just switching on a signal, right? And then you can make a device blink for every 1 second, right? It's a programming that you do with the hardware, right? It's not really a programming way. And then, yes, and then an assembly, uh, programming where, uh, you do understand, you do okay, to put it in simple terms again, an assembly programming is something like hardware understands few of the operations, not everything. They just know how to do add, they just know how to do sub, they just know few of the instructions, and we call that instruction set, right? Every hardware comes with possible instruction sets. And the instruction sets, are something which are hard coded in the hardware. So now, by using these instruction sets, which are, created by logic gates and other things, which will be a complete different direction to understand. But just to come back again, programming is a simple way of teaching hardware to do things. Yeah.
So, do you think understanding the fundamentals of computer science is important in understanding a programming language?
Sure, to some extent it is, but it's not true all the time. We
Okay.
do, we do have a use case, or we do have a complete stream where you actually use programming language to create new things, but you don't really get a chance to understand the internals of the computer as such,
Yeah.
right? You don't really need to know, let's say, virtual memory to understand that, oh, when I am downloading a big file, right, my code might not work, right? You don't really have to think that. Or sometimes, oh, when I'm printing something to the console, it might not work, right? We just don't think that. We just say like, okay, I printed, it shall print, right? We don't think like, uh, how many, to put it again, like, in a questionary format, right? uh, People really don't need to understand how many milliseconds would it take to show something on the screen when they type print. Because for to answer that question, you need to understand everything, right? You need to understand data bus, instruction bus, how does the CPU fetches the instruction from the RAM, how does it gives it to the kernel, which is the actual one who can actually speak with the hardware. Again, there are a lot of internals, but I'm just trying to give a high level picture here. The CPU just tells the kernel, and kernel is the one who interacts with the hardware, right? So during all this flow, how many milliseconds or how many nanoseconds would it take, right? We don't really understand. All we do is you just do print and you just expect it to show up, right? You do a uh, API call. Uh, Again, API call for to make it easier. You're calling a function which is not inside your laptop, somewhere sitting somewhere in the Australia or US, right? You're just calling that. That's called API, to put it in again simple terms. Um, then you don't really expect, oh, my network drivers are working or not, or did I open the socket properly or not, did I close the socket properly or not, right? All you do is like, okay, you just call the function, you just expect a response, whether it's a failure response, success response. That's all the users usually care, right? They don't really need to go to the deep of computer science to really do the programming these days.
So I have one thing in my head, like I need to set up a website for myself. So what can anyone uh, think when they think of setting up a website? Like what programming language that they need to choose that their task can be completed. So what are the steps that they need to take to choose the best programming language for their task?
Sure. See, the very first thing that anyone has to do is like find the compatible language,
Okay.
uh, because there is a possibility you like C, but you can't really build a website with it. Again, when I say you can't really build, the easiest way of building it, right? To be honest, you can build a web browser, maybe website even with an assembly, right? It's still a possibility. But the only thing is how feasible it is, how, because your problem statement is creating a website, not really creating a particular language, right? You want it to be done as much faster as possible, right? So you first have to like met that criteria, what are all the possible languages. Then you look at your product requirements as such, as in, is it a static website or is it a dynamic website? Are you going to update things very regularly, or are you going to be something like you just put it and maybe update once in a year, or 6 months or something? That's a choice again. Along with this, there could be other product requirements as such. Let's say you want to make sure your website loads faster than anyone else, right? You wanted to have that as your MVP, you wanted to have that as your selling point, right? So you can just extend all the product features. And then again, let's assume you just create a small uh, table, okay? You just put all the languages that you know which are all compatible, then you tick them. Which are all matching your product features, you just tick them or give them rating, saying like, oh, language called X is a 0.5% in 0.5 in terms of performance, 0.4 in terms of security, right? Because there is a security concerns, you don't want your code to be hackable, to put it in a good terms, right? You don't want it to be hackable. And there are like a lot of other product requirements usually think. Definitely the third requirement would be something more or less like, what is the future of that language that you're picking?
Okay.
Is it something really um, doing what is it saying, or is just a sham, right? Yeah. Or is it just a sham, right? And like this you can continue in terms of features, and then you might find a few languages, then you would notice some of the frameworks which are helpful to easily build a website, right? And you can extend the same ideology to any kind of product, not just websites.
So suppose if I'm buying a phone or a laptop, we'll see for how much RAM it is, what are the cameras, and what is the OS or the brand that it is backing up. So these are all the things that we see while we are buying a phone. So in that context, what we should understand while approaching a programming language.
Yeah, definitely, it's a very good question. I feel there is like two sides of understanding. One, I would like to call it a hardware side of understanding. Another, I would like to call a software side of understanding.
Okay.
uh, to be honest, majority of the focus happens on the software side of understanding a language, which would be more or less like, how to write the code, what is the right way of writing the code, what are the patterns you can use to write a code in a better way. um, um, like what are all the libraries that are available, what are all the frameworks that are available, how fast can I write this code, how fast can it run. These are all software side of programming, right? Which most probably everyone would think, not really a, a unknown side of it. But when it comes to hardware side of understanding programming, it was not very much into the people. Not many people really shows interest on understanding it, uh, which are more or less like, how does the parser of this language work, how does the tokenizer of this language work, yeah, how does the intermediate code representation of this language was there, what kind of optimizations does this language compiler do while it's compiling the code, how does it add the other libraries, linkers, loaders,
Okay.
what is the intermediate framework it uses to generate my assembly language. Does it, if I have one line of code in my language, how many instructions does it really generate, right? Because you think, okay, I wrote a very good algorithm which is O of 1 or O of n, right? But
Mhm.
the moment it goes to instructions, and the instructions which are generated are 100, right? Even though in your mind it's so efficient, it's not efficient on the hardware. And also sometimes it's like, not, again, not many people need to know this, because it's not like always you get a specific hardware, right? Some people do work on a specific hardware, but they do get onto the hardware side of understanding a programming, right? So I would really suggest everyone to also start focusing on the hardware side of programming. Try to understand the optimizations the language does, try to understand the steps that compiler really does, and along with that also try to understand what makes this language different. So for just to give an example, right, Rust is a programming language which doesn't have a garbage collector, right? For me that's something, uh, a selling point, right? For me, when someone tells me, okay, why do you have to use a Rust, I can simply say, not because it doesn't have a garbage collector. Then you can ask me, okay, it doesn't have garbage collector, how is it going to be helpful? I know it's going to be faster. Why do I know it's going to be faster? Because I understood some part of the hardware side of programming. I do understand what actually happens with the garbage collector. How does it affect your performance of your code, right? Which we don't usually talk when we are writing programming questions and all. We just take care only about the asymptotic notation of complexities, right? But that's not true as you enter into the industry, or as you enter into the hardware side of understanding programming, right? That's no more true.
The next question I'm going to ask is like, uh, most of us in our country know cricket. We play cricket, but only 11 players make it to the World Cup team or any team. So what we understand is we know the theoretical part of cricket, but only practice and make it to the team. So how can we
Hmm.
balance in terms of programming language? We need to know the theory as well, and we need to
Hmm.
know the practical side as well. So what is the balance equation on this both in terms of programming language learning?
Sure. I think in this analogy, with respect to programming, it's kind of vice versa.
Hmm.
We have only 11 people who knows the theory,
Yeah.
but we have thousands of people, or the crore, as you compared with the Indian population, 140 crore people of people know how to do practicals, right? They just know how to uh, write code, right? So I think the analogy is kind of vice versa here. But I think, see, to some extent, right, this is working,
Hmm.
because you have to ask what is your end goal, right? Let's say your end goal is to build a product, or your end goal is to work for a company, right? Definitely it's working. You can see the scale, right?
Hmm.
And why is it working? Because, see, think like this, right? How many people does really need to understand the internals of the language, right? Maybe the people who are working um, on a specific hardware, maybe the people who likes to build something new, or maybe the people who had a experience with the current language and they saw something was wrong fundamentally and they wanted to create something new. That group, right, only comes with experience, or more or less like, uh, has nothing to do, sometimes it has nothing to do with programming language, or the job, or the general vision of people, right? So I
Mhm.
think there is a very big detachment here of what kind of mindset you should have to be the theoretical person versus what is the reality, right? Theoretical is little far from the reality,
Mhm.
and it usually happens with a, research fund by companies, research fund by some unknown people at higher level, or research fund by colleges, PhD thesis and all, right? Most probably the projects that you're talking about, right, that 11 people in compute in programming language has to be funded, and they has to be like very clear on what they're building. Other on the other side, the large population doesn't really need to know what they're building on the day zero.
Mhm.
They just build something, they'll reiterate, they'll find a bug, they'll fix it, they'll reiterate, add a new feature, find a bug, fix it, they'll reiterate, right?
Mhm.
So there is a completely two different cycles happens here. So I think uh, with Gen AI and other kind of things, right? Maybe more people might be interested towards moving these kind of things, which will have a very small, um, maybe it's a very small amount of work in terms of the impact that it could have in it could have in the early days, but
Okay.
it'll take huge amount of your time. It'll take huge amount of your understanding. It'll take huge amount of your vision. It'll take huge amount of pattern matching things, right?
Mhm.
Because it's not like you can ask Gen AI to maybe like create a programming language without garbage collector.
Yeah.
It can, but for us to understand with the hardware, with other things, with how the people comfortably likes to write the code, right? Creating a language would have a very different impact on at least on the today's basis.
Okay. So if suppose like some students are more well versed in Python and some software professional is well versed in Java and some are well versed in JavaScript for the front end and everything. So how can they approach new programming language if their company demands or they need to enhance themselves in their personal learning? So how can they approach a new programming language or learn a new programming language, leaving the programming things that they have learned from their previous programming language and the syntax and all?
Yeah, yeah, most of the times you don't usually leave things,
Okay.
but majorly you leave the syntax part of it. Again, coming back to that hardware side and the software side of the programming, right? In software side you would replace it with few other things. How does the imports will work? How does for defining a function works? How do I define a variable? Again, it's not, it won't be so much different. It will be only 10-15 questions you have to ask in terms of syntax, right?
Yeah.
Like that. uh, in terms of frameworks or in terms of libraries, you just have to ask some 10 questions. Okay, what is the basic library to create a REST API application? What is the library to do this? What if the library to do that, right? And then on the other side there is a hardware side of programming, right? Where you have to ask questions like, okay, what kind of garbage collector is this using? Is it using mark sweep, or is it using generational, or is it, or doesn't it have any garbage collector? What kind of code optimizations does it do? Does it do inlining? Does it do specialize? um, does it do other kind of code optimizations, right? On top of that, something like, okay, how does it generate the instructions? What is its process? um, does it have any intermediate representation? Does it have an extensibility? What kind of parsers do they have? What is their parser looks like?
Mhm.
To even put it in another words, what is their grammar looks like, right? We do understand grammar,
Yeah.
at least in general sense. What is a programming language grammar looks like, right? So I feel replacing the software side of programming is not really a complex problem,
Yeah.
right?
Okay.
You just need to understand few of the things, and you take the same concepts, you write some code in C, you take the same problem solving concepts and you just put it there. Maybe let's say in C you have used a pointer, but when you comes to Java you don't have to have anything called pointer, right? Why? Because let's say the linked list or something else have to be implemented in objects format, objects and classes format, right? So only those things are changing. Again, that I will still call it as a software side, because it doesn't really talk about what is pointer, how does it work internally and all, but it majorly talks about, oh, I have a pointer to solve this problem statement, here I have an object to solve it, right? So along with these two, there is this top level differentiator, which is like, let's say when you move from C to C++ to Java, right? They say it's an object oriented programming language.
Yeah.
So here it object oriented programming language, understanding that, right, you don't really have to start coding it up.
Yeah.
It's a concept, right? They're just talking about a different way of writing code, even though it's majorly falls on the software side of programming, but I wanted to highlight it outside because it's more or less like um, helps you to understand things in a different way. It more or less like helps you to write the code in a different way in this language, right? So I'll say something like you understand the differentiator first, and then you understand the software side of the programming, what is the differences, and then you understand the hardware side of differences, right? So and to be honest, you don't really need to go to the hardware level most of the time, and you can still able to work in the new language. And just to give a like last touch for it, so there is a concept called transpilers which you can actually use to translate one language into another language.
Okay.
So if you're really like a person, no, I wanted to write in only one language, but my company wants me to write in another language, right? Then why don't you build a transpiler which will take your language and converts it to that target language? Good idea.
Uh, okay. So I want to learn more about this transpiler concept that you said. So what is a transpiler actually? So does it convert every programming language into whatever programming language do we like that we deserve, or is it in the starting stages of the design where only it is limited to some of the programming languages, or do we need to deep dive into more of this transpiler?
Yeah, again, transpiler is more or less like a concept, like how
Okay.
compiler is there.
Okay.
It's more or less like a concept, and it just usually suggests you some patterns of doing it, but it itself is not a framework or a language or a direct right away solution. You just can take it and convert between languages, right? um, but usually it goes in this way, right? You take a source language, okay, you do understand it parsers, you do understand its hardware side of the programming language, and you give it to your another code
Okay.
which knows how to convert the AST of left side program, which is a source program, into the AST of the right side program, which is your destination program. So you can say transpiler is something which can convert an AST to another AST. So
Okay.
transpiler is simply a tree conversion. You
Okay.
have one tree, you just have to convert to another tree. That's it.
Okay. So my next question would be like, as we have established before that learning a concept is more important than learning a programming language, how important is it learning the basic algorithms or basic data structures that are there and converting them into the format of code in any programming language? So, how is it important?
Sure. I always felt most okay. This is how I have always seen it, right? So when you talk about data structures or algorithms, right?
Yes.
I felt they most probably take you into the company, as in it will give you a easier path to crack an interview,
So,
right? So, not not to definitely not to 100% or definitely not to the level we see outside. Okay, so
okay.
because as I said, right, not every company is creating a Gen AI. Not every company has created a Chat GPT. To even put it in a better words, not every company has created a transformer architecture, right?
Okay.
But every company is using the transformer architecture to build new things. Okay, so not everyone has to work on the problem solving level. Few people can work on uh, uh, expanding of the problem solving, as in you can expect someone to create a data structure, you can expect someone to create a easier layer for you to not to deeply understand the data structure, but you can still get the job done. You can still start a company, and you can still make that company a trillion dollar company, right? Directionally that's possible at this moment, right?
So,
so
if I
so
have a solution for the problem that I have, what you're saying is first solve that problem and then
uh-huh.
get people who can optimize on how solving that problem is. Is that
Yeah,
what you're
yeah,
saying?
yeah. Yeah, directionally it is. As I said earlier, right, how do you choose a programming language? You usually have some product features, right?
Okay.
So let's say your day zero statement is like, I don't want my code to take more than 1 second, right?
Okay.
See, now you have put a strict deadline on it. Now it's no more just about the data structures.
Yeah.
uh, Sometimes you used a list rather than a hash map, but you're still able to get the job done in a better way. Why? Because you understand how does the CPU works, you understand how does the copy of the caching works, you understand how does the parallelization in the CPU works, you understand how the concurrency work, you understand how the paging works, you understand how the fragmentation of data works, right? With all these concepts, you are able to write code which without this concept might look like, oh, this is not a performant code, right?
Mm.
But when you run it, that will be the performant code than the one that's not, right? Uh, so so to put it in like general terms, I feel 90% of the data structure or algorithm understanding takes you into the company.
Okay.
10% of it would really have an impact, whereas on the other side, 10% of your understanding of computers or the internals or the basics, right, or the fundamentals would help you to get into the company, but 90% of would make a change in the society, right? Because that 90% of understanding of the computer only made homomorphic encryption, transformers, whatnot, anything you talk which felt like a directionally taking us somewhere in the future, right? That
Yep.
happened because of 90% of understanding of computers, not because you understand 90% of existing algorithms, existing data structures, right? So I think if you put a graph, that's how it's going to look like.
Uh, from your example, like how companies decide on what they need to use and optimize the code. Do you think that companies are dependent on the programming languages that they are used? Because most of the legacy applications are built on Java and they are still doing all the bugs and debugging everything in Java instead of converting them into new programming languages. Is it important that converting applications into new programming languages helpful, or leaving them in the legacy applications and just providing maintenance to the code is more preferable?
Yeah, as I said, right, in how do you choose the programming language, the one of the major thing is you understanding the direction that the language is going towards, right? So as you said, it's a programming language which was using in legacy application, but is it like that language is not getting updated? Is it like the language is not getting, let's say, the capabilities of, let's say, GPU? Or is it like the language is not able to take the advantage of the new hardware? See, then directionally, it would make more sense for us to move to the new languages. But
Mhm.
one of the major concerns you would see was like when you are moving to new languages, right? You have to get your testing done. So there is this lot of baggage, lot of many years experience, right, has to be sitting there while the conversion is happening. It's not like you have an hello world program and you can convert into Python or something, right? You would have like huge code which is impacting the real lives in daily life, right? So so yeah, there are concerns in terms of security, in terms of uh, testing, in terms of this baggage. What could break when I change something, right? You don't know really. You need
Yeah.
to have a very good testing framework to make sure that your movement happened very smoothly, right? Another thing is like, okay, you move to the new language. Are you sure that this language is something that can work for another 10 years?
Mhm.
How did you make that bet? Did you understand the internals? Did you make that bet with a confidence, or did you just read couple of blogs, or you just noticed, oh, this language is hot, this language is being used by everyone, Google and all, let's pick it up, that language, right? So directionally, if you don't understand the basics, if you don't understand the uh, if you don't understand this language from the first principles, right, which I would say the hardware side of the programming language, most probably you would never stop. You always feel like, okay, I have to transfer it to new language, right? But I think most of the times the companies don't do that. uh, might be for the another reason. That another reason is, as I said earlier, the security testing, the code baggage it brings, the experience, and hiring new folks. I think it's more or less like in the management side there are concerns, but not really on the side of understand the basics and all. But it would be good if people also spend some time on understanding these hardware side of programming language to make these decisions, because it will really have a big impact.
Yeah, let's take a diversion from corporate or company side to an individual learning perspective. So, how can one evolve from learning the basics of programming language to building complex projects? individually
Mhm.
and just
Sure.
become a maintainer of any open source project or anything? How can they evolve from that beginner step to a project maintainer or a project uh, uh, like
Yeah, got it. Again, I think on the top level you have two directions here. One is you have to get comfortable with the basics of the programming language. You
okay.
have to understand. Again, when I said understand basics, it doesn't mean syntax. It doesn't simply mean okay, I know how to write a code in Python. That means I understood the basics of Python, right? You just need to understand the interpreter. How is the interpreter of Python working? How does it do things? How does it store a integer? How does it store a float? How does it store a string? When I do a lookup in string, how does it happen? When I do a lookup in a list, how does it happen? All these concepts, right? You just have to understand. On the other side, you need to understand what is the easier way of maintainability of the code, as in to what level you have to modularize your code, to what level you have to do that such that you can add new features very easily, or you add a new feature, it doesn't break something else somewhere in the code base, right? You added something in one file, but when you're testing some other file, something is changing, but which you felt by looking through the code that they are no more not at all linked, right?
Mm,
It's like I changed user image, but my all the searchable images are changed to that image, right? I searched for Apple, and I around that time I changed my image. It's not like all the Apple images looks like me, right?
yeah.
And to be honest, to be even like it feels silly, but to be honest, if you just search, right, you would find these kind of incidents which are funny, but they took a lot of downtime. One of the major reason is simply because the modularization is not to the right level, and there is something called uh, I just want to use the word builder pattern, but in general I want to talk about the way of writing code. There is a way of writing code which can let you to solve some of the problems, right? Which is maintainability, composability, extensibility, and little bit more on that side, right? But by just having these two directions, and by just you realizing there are these two directions, and whenever you're writing a even a one piece of line of code, right, by putting a thought through these two directions of the tree, right, you can actually able to write the line in a better way, rather than thinking okay, I'm writing it now, I don't care how it's going to be rewritten 10 years later, right? I have
So
this
I want to ask a question. Sorry for interrupting. So, do you think, in this context, the art or the approach of learning a programming language has evolved in the past decade? Because we've seen most of the software industry booming in the last decade, last 20 years, we could say, like 2 decades. But in the last decade, we saw the increase in use of hardware resources like AWS and Azure, and more startups have evolved. Even in India, the digital marketing side has evolved a lot with the implementation of UPI and the new banking systems of OTP and everything. Do you think the approach of learning has improved significantly in the last decade? And
yeah
the trajectory is going towards stagnant state. Like we had iPhone 1, iPhone 2, and it kept on evolving. But the approach and the programming languages, like in the same way, the approach and the programming languages have seen a boom. But I think it has become a stagnant state, same as the innovation in the mobile space. So, what is your view on that?
I am not fully sure on the saturation point at this moment, because I feel it's still like lot of room is there. But yeah, see, definitely the software has become so cheap, right?
Yeah.
Now, you writing a piece of line and just testing it and just changing it, again testing it, changing it, testing it in a very big environment, hundreds of users, thousands of users, doing a staggered releases. See, since a lot of new things come up and which made the software become cheaper, right?
Hmm.
That this evolution happened very very rapidly. So
Yeah.
let's take for example, you have Kubernetes, right?
Yeah.
Which made people deploy things very much faster, which made things which made people to test things much faster. There is a concept of traffic splitting. You can deploy two versions of the same code base, or the old version and the new version, and you can send only 1% of the traffic to the new version but still 99% to the old version, right?
Kind
In
of
the
load
earlier,
balancer or a new concept?
it is a kind of load balancer, but this is little bit more intelligent because you can do at
Okay.
the API level, and it can maintain something called rate limiting. It automatically can revert the traffic, which is definitely there in load balancing, uh, such as Nginx or other sorts
Yeah.
of those guys. But the problem is setting up these things were like more costlier. Setting up,
Okay.
maintaining these configurations and these things are more costlier, right?
Okay.
Hence people are little skeptical. They're like, okay, let's not do it every day, maybe do it once in a week, once in a month and all, right? But now with Kubernetes and other things like Istio and other things come up, right? Things have become a little bit more cheaper. Trying out things become cheaper. So when I said software become cheaper, the whole pipeline has become cheaper, right? You can just try
Okay.
it out. That's simple. Okay. So hence, see, when things were that cheap and when things were easier to evaluate, right, definitely
Mhm.
people would try it in different directions. They don't follow a hard strict procedure someone has set up, right? Oh, you have to write like this only, you have to do it like this only, it has to go in this way only, versus it's okay, man, just write on a different way that you felt okay. If I write it in this way, would it be any better? Just write out, put it in prod, nothing is going to go bad, right? Only 1% of the people might get affected, you'll just revert it, right? And it's an auto reverted. There's a feature called auto revert also, right?
Yeah.
So action as a playground, trying out things easier, software becoming cheap, right, are some
Yeah.
of the things that actually made this evolution happen faster. And why I said it haven't reached the saturation point is because I do see some gaps in this process. It's not like 100% well set. It's not really like uh, you have a very good pipeline of starting a idea to letting it run in the prod and automatically finding the anomalies, automatically making the code change based on the errors that you got.
Yeah.
And I
Okay.
think here a little bit of Gen AI is going to come and make people be even more better, or can do code reviews in even more better. I think a whole set of new direction might open up with new things are coming. So I don't really think it's at the saturated point, but I do agree with the point that it evaluated in a very very exponential way in the last 1 or 2 decades.
I want to learn more about this Gen AI, like the impact that it has on programming. And I saw an example where one of the YouTuber was sharing a code in Python to an LLM like ChatGPT and asking it to convert to another programming language. So it is kind of becoming easy. Like we have previously discussed about transpilers.
Right.
So can LLM be a transpiler, or it is actually translating code from one programming language to another programming language? And I
Right.
think in future it will be more optimized and it will be giving more accurate code in other programming languages. So do you think
Yeah.
that its impact is significant in this programming languages?
Yeah, it'll definitely gonna be, and maybe in the next I won't think it's gonna be way far. I think it's very very nearby, and we will see it in very near future that a lot of these new kind of programming would really pop up. To put it in the transpilers term, right? uh, the only concern today for me, or some of the people who are thinking about transpilers, was like the determinism of the LLM,
Yeah.
right? Because okay, there is a concept called temperature. There is a way for you to make the output deterministic, but when you put something deterministic, it might not predict in a right way, and there are some concerns there, right? So it's not really a deterministic way of uh, getting an answer. And to be also, another concern is at this moment, not it was not trained on huge set of code bases. Okay, maybe ChatGPT for sure, because ChatGPT is almost 1.3 trillion tokens
Yeah.
in a trillion parameters, is it right? It would, and it scraped a lot of data, and it would definitely have to some extent used coding for the pre-trained. But there is this another set of LLMs which are coming, which are usually called code LLMs,
Yeah.
uh, which was majorly open sourced by Meta, and there are other people like Salesforce, and there are some of the big companies who have open sourced these models.
Yeah, I
So
think
you can
Blend Studio is the program that where it's an open source program where we can download these LLMs and run them locally.
you,
And
you can actually it's called Hugging Face. Uh,
LLM
but
Studio is the like the front end that they are using for the Hugging Face one. So that is one of the program that I saw yesterday.
sure, but you can't literally run it on your local laptop because you need a GPU.
Yeah,
So you can use something like Colab of Google. But
we do
I
have a
think
GPU, so that's why I'm running them locally.
yeah,
So for those who are listening and don't have a GPU, run it on
yeah,
Google Lab.
you can't really do it, but you can do it. Like Colab Google gives you a good enough a CPU and good enough memory, RAM. I mean VRAM. So yeah, you can try out things, but yeah, I feel like at this moment, more ideas are gonna come on here. It's not just gonna be something like code LLMs. They can even become more particular on saying like code translator LLMs,
Okay.
um, or something like code summarize LLMs, or something like code optimizer LLMs, and I think that the directionally it's going to be so much. But for that, we need huge amount of data, and the data also has to be very well processed. And if you don't make sure uh, we have this good enough of data to train an LLM, right? It won't be of much use. So at this moment, I think uh, a big company like Meta or Falcon, or which is Tesla, by the way, or any of these big guys, right? Salesforce, they have a lot of proprietary data. They have lot of uh, they have capability to run on lot of GPUs to really pre-train on code more and less on an NLP, because see, we don't really expect it to generate a Shakespeare Hamlet, right? We expect it to write a code which is compilable, because right now if you see there are scenarios I've noticed when I ask something to ChatGPT, it gives a code which is not compilable at all.
Yeah.
I have to make more changes on it, and I do understand why, because I do know that the data that was LLM was trained, the ChatGPT was not so much of a code. It's very less. And sometimes I ask in a programming language which where the knowledge about that language itself is not so much outside available, right? It's a very few people use it, something like APL or I don't know, like some of the languages, right, which not many people would use it, right? And you ask for LLM, there are high level of chances it might not give you 100% compilable code, and we usually call it hallucination or a bad response from an LLM, right? So yeah, directionally, not only in the code, but in all streams of computing, not only in the computing, in all streams that usually people work, right? I think LLMs would replace, but it's more or less like going to be a together work, and that level of replacement might take many more years, but because at this moment, um, the data is not big enough to just replace it with every problem statement, just let it answer you for every problem statement. It's not feasible at this moment, because it might not even see that data ever, right? So I think yes, with CodeGen and all, you would find a programming buddy,
Mhm.
and he will help you with some of the hurdles, but at the end you will like make the decisions, and maybe you will finish it up.
We have a guest today with us, so he has a question for you from one of his programming days. So I want him to take away and ask the question. You were breaking, so can you repeat the question again? Hello.
Remember the timestamp, no? You can edit it off.
Were you able to hear his question?
No, no.
I think he is having. Yeah, we got him.
Sorry, can you give me can you give us some information on foregone function inference?
Were you asking about foreign function interface?
Yes.
Yeah,
Yeah.
sure.
Sorry. Yeah.
So basically, uh, foreign function interface is just a way of letting one programming language call another programming language for a particular problem statement, right? Let's say uh, C is very good with socket level programming, right? And you are using some other programming language to do something, but you noticed your performance will be so good if you would have let this one piece of code, let it run in C, right? But rest all you still want it to be in your own programming language, right? You would like it, okay? And hence there is a conceptually there is something called foreign function interface, and it have an implementation in a different way. Sometimes they do share a memory, sometimes they don't share a memory, but they directly call the runtime of the language. And there are other ways of implementing this, but it, on the top level, what it simply does is it lets you to call another function which is in another language to get a job done, right? You know, exact like foreign function interfaces are not new, it's been there for many years. And also I always feel API is in another foreign function interface. You
Okay.
write code in Java, but you call, like, let's say you write code in JavaScript, which is your website, right? But you call something in your backend to do something, right? But that code was written in Java, right? But you're still able to invoke that function from your laptop, right? From your JavaScript code, it's still possible. But they're not that far in terms of FFI. So we usually say FFI is something like in the same problem statement. For a small piece of code, you just wanted to give it to another runtime, let it run in C and come back to you.
Right.
Okay.
So would it create any kind of delay if you are communicating with other languages, and you also have to control various aspects such as memory and runtime in another languages as well? So
Yeah.
you're not
Yeah.
only managing one language but also other languages as well. So how,
Yeah.
as a software engineer, how would you maintain this problem?
Sure. Generally, this is not fully true if you're writing it in C or something, because most of the languages do convert to C, not to the Ansible C that you see, but to some level of C. Then it goes to assembly, right? So they can
Right.
usually inject your C code there. We usually call it linking or loader, some sort of that way, right? So then you don't really have to worry about any kind of overhead, right? In performance. But there are other kind of languages, let's say maybe Java, right? Not Java, sorry, maybe JavaScript, right? There you can't really have a interoperability with another language like this. Why? Because the first reason is JavaScript is an interpreter language. There is nothing called compile, right?
Right. Yeah.
It has to take each and every statement, it compiles, right? It doesn't know when to inject the language. It
Mm.
doesn't know when to inject that other language, right? Usually JavaScript have a interoperability or the FFI with WebAssembly. It's an another uh, uh, I don't want to call it a language, but it's another way of doing things in browser. Okay. uh, as you have JavaScript to do things in browser, there is a WebAssembly way to do things in browser. But you want some small piece of your website to run with WebAssembly code, right? You can do it, but it doesn't go in the way that we just explained. It usually goes in a way of shared memory. They just share a common memory, and WebAssembly would be looking at that memory. And when JavaScript wants to call WebAssembly, it just writes to that memory, and WebAssembly will realize that a signal came, and it will pick that code and the instruction and the data, and it runs it. And again, it puts it in another shared memory which was being listened by the JavaScript, and it realizes, okay, it put the value, now I know it's a value, right? So here definitely there will be a little bit of performance overhead, but again, all these things would go away as you go into the deeper layers of hardware understanding, right? Maybe on the top level it feels like, oh,
Mhm.
that is a completely different runtime, this is a completely different runtime, there shall be some performance overhead. But as you go open up the layers and as you try to understand, right, you would see at some level these two are no more different, they both are same. Whether it's JavaScript or whether it's WebAssembly, they might be same. And your foreign function interface might have been implemented on that layer, then you don't see any overhead.
Right.
I think that concludes today's podcast of what programming languages are. I think we have leveraged a lot of knowledge on from you in this podcast. So I think we'll continue this on our next podcast episode. Thanks, everyone. Thanks, Surya.